Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with LearnBay.co. Happy learning!
Next, actually, we can see Apache Hadoop. Okay. So already said it's like a big data is a term. Okay. So big data technologies in the sense, big data in the sense, a lot of technologies are there. Okay. And one of the best is Apache Hadoop. Okay. So it's like Apache Hadoop is there, Cassandra is there, MongoDB is there, and so these are all the some high level technologies. Okay, after getting into so many other technologies like a Spark, Hive, Pig, okay, and many other technologies will be there and all. Okay, but in the high level we can see, I can say that one thing is like Apache Hadoop, Cassandra, MongoDB. Okay, some different things and all there. Don't get confused. Then what is the difference between this, that, and all? Every tool has its own characteristics. That's what. Okay, and based on your scenario, you have to pick the right tool. For example, if you compare with RDBMS, okay, under RDBMS you are having Oracle, you are having SQL Server, you are having MySQL, Postgres. Okay, different kind of technologies. See, we can see these two, like Oracle and SQL Server. Oracle from Oracle Corporation, SQL Server from Microsoft Corporation. Okay, and more or less both are same only. Okay, you have to create databases, and inside the databases you have to create tables, and the tables will be structured. Or if you are working in Oracle for 2-3 years and all, maybe within one day you can without any constraint you can work on SQL Server straight away, because it's like more or less same only. Okay, but it's not like in this big data. Okay, different tools will be having its own characteristic. We can say that Apache Hadoop. Okay, then Cassandra. What is Cassandra? What is MongoDB? Okay, actually, if you are using, in case in your scenario you want to store only these documents. Okay, only if you want to store document-based data, you can use MongoDB. Okay, and if you want to see some kind of structured data, but you want to store a huge data, but mostly it is structured in the sense you can use Cassandra. Okay, if it's Apache Hadoop in the sense, if it is like a mostly structured or unstructured anything, you can use it. So based on the scenario, you have to use it. Nothing actually. It's like, is it Cassandra is competitive to Hadoop? No. Is MongoDB is competitive to Cassandra? No, because Cassandra is having different kind of characteristics. MongoDB is having different kind of characteristics. Okay, that's what. So there will be many tools are there. Okay, one of the best tool is Apache Hadoop. Okay, so that's why actually if somebody people will say that I'm working on big data in the sense, even they work on Hadoop itself, they say that they are working in big data. Okay, so because most of the big data users are using Hadoop, it is like a big data in the sense Hadoop. They are saying that if I'm working on Hadoop in this, they will say that I'm working on big data. Okay, so actually it is not true. Okay, different technologies are there, but most of the people as they are using Hadoop, so that they can say, okay, Hadoop in the sense it's like a big data in the sense it's a Hadoop, like they're saying. It's not actually. Okay, Apache Hadoop is one of the tool under big data umbrella. Okay, and also it is one of the best tool. Right? So why actually the Apache Hadoop we are using in the sense, we see this actually basic.
Apache Hadoop is open source?
Yes, most of the big data tools is open source only.
Yeah.
Okay, and Hadoop is open source. Okay, right. So this Apache Hadoop. Okay, here actually, if you see this definition, something if I read it, Apache Hadoop is an open source software framework used for distributed storage and processing of data sets of big data using the Mapreduce programming model on a cluster of commodity hardware. Okay, just it's like looks like a definition, but it's this single paragraph is having a lot of keywords. Okay, I'll explain in a way. Before that, just I'll explain what is this Hadoop, why this elephant came with this. Actually, the Hadoop was developed by the person called Dog Cutting. Okay, Dog Cutting. Actually, Google developed a distributed file system. Okay, kind of a big data around 2005, I think so. Okay, Google developed like a a distributed file system, some kind of tool actually they developed it. After that, they published that white paper. Okay, based on that white paper and dog cutting and his team, they developed this tool, Hadoop. After this developing this tool, and they want to name it for this particular tool. And the dog cutting is looking around. His son was playing with an elephant toy. Okay, the elephant toy name is Hadoop. Okay, so he came gave the name as a Hadoop with this elephant logo. Okay, and after that, they gave it to Apache. So Apache is maintaining, and they are providing in the open source and all other they are having. They are providing all those services. Okay, that's it. So this is actually history about this Hadoop and all, and generally we'll say Hadoop, or it's like we can say Apache Hadoop and all. Most of the big data tools the people are using this mostly open source only. It is provided by Apache Hadoop, Apache only. Okay. That's why we say Apache Hadoop, Apache Hive, Apache Spark, like that. We'll say. Otherwise, we can straight away we can say it's a Hadoop. Right. Hadoop is an open source software framework. Okay, this is one first keyword. It's like an open source software framework. Okay, and it's like a used for distributed storage. Okay, that's what actually we have to understand. Distributed storage. Okay, so this one keyword, and processing of data sets of big data using Mapreduce programming model. So this is one keyword, Mapreduce programming model, and cluster of commodity hardware. Okay, this is the fourth keyword. It's like an open source framework for distributed storage. Second, processing with Mapreduce. Third, and cluster of commodity hardware. This four and all. I'll explain one by one. So it's like an open source. We already understand that's like what's open source and all. It's like a distributed storage. Okay, so distributed storage in the sense. Okay. Yeah. So for example, you are having one server or one system. This is one server or one system. So you are having the data capacity of something like 2 GB. I'm sorry, this is the maximum capacity. Okay. So what we can do? So if it is like an individual system or individual laptop, or it's like an individual server, when the it exceeds its storage limit, we'll take and backup. Okay, we'll take and backup, and we'll keep only the latest data. So that's happening. Otherwise, what we can do, in case if we have one more server in the network, okay, one more server in the network, and also it is also having the nearly same data size. Maybe if it is like a 2 GB, 2 TB, and this is also 2 TB. Okay, like yeah, you can store 4 TB of data, but you are storing on different systems. Okay, it's like a different system, and traditional way I'm talking. Okay, so here once it is full, and it will be here and in case if you want to access the data here, you have to come to this system. Otherwise, you have to go to this system. And if you want to process it together, what you have to do? You have to write, set up your network like that, and your programming like that. Okay, it's like connecting to two systems. Take from here, and you have to process it. That's the traditional way and all. Okay, but you just imagine. So this is like a 2 TB. This is 2 TB. Once this is full, and next you are storing here and all. So if you connect both, okay, if you connect this both, sorry, yeah, if you connect this both, and virtually it is like it is 2 TB. This is 2 TB. Okay, so it is like 4 TB of data you are having it. If you add one more thing like in the system, another 2 TB, it will be like 6 TB. Okay, and you have to say that it's like your data is distributed. When it is full, and it is going to next system. Okay, once both are full, it will go to the next system, so that you are distributing the storage. Okay, I'm just giving generic example about this distributed storage, but Hadoop won't store like this. Okay, Hadoop won't store like this. Okay, Hadoop stores in a different way, but you have to understand what is distributed. So distributed in the sense, if it is a cluster, so cluster in the sense you already know. Okay, so it's like more than one system joined together, that is a cluster. Generally, cluster in the sense, it's like a 10 system. Earlier, server in the sense like a 3-node cluster, like 3 system cluster, 6 system, 10 system cluster. They'll say that. in a cluster, in the sense, it's like inside the cluster more than one systems will be there. So, and it is like a joined together. That's what. So it's like in a cluster, multiple systems will be there. Your data will be stored on distributed way. So this is full, and next it will go. But virtually it is all together. Okay, compared as a single system. So that's what actually distributed storage. But just understand this generic example. Somebody, can you put your mic? This one, mic and mute. Yeah, thank you. Okay, so that's what you have to understand this distributed system. But when I'm getting into Hadoop, I'll show how actually it is storing the distribution. Okay, I'll say I'm just muting everyone, but you can unmute yourself. Okay, if you want to ask question, Nada.
Yeah, one question for me.
Yeah.
Just so if we have systems, if we 10 systems, it is separately dedicated for that one, or we are using that system and
no, it is like a cluster inside the cluster, so that is only for data only.
It is separately kept it aside. We are not using those systems, right?
In case if your company they are using Oracle, okay, Oracle to store in the sense, so they will not have one single server. Okay, if it is like a big company, definitely at least for backup and all, they will have 2 servers. Sometimes if it's a huge data, 4 or 5 servers, they will be having it. So that call all 4 or 5 together, one cluster, one Oracle cluster. Okay, that dedicatedly for storage only. Okay. So this is actually the keyword you have to understand: distributed storage and also processing. So what is processing in the sense? It's like you are storing huge data, or whatever the data you are storing. Storing is not enough. You want to do some processing about it. You want to do processing in the sense it's like analyzing, querying, everything is a processing. Okay. So if you want to processing of this data, they are using a Mapreduce programming model. So that's what actually the Hadoop is using. Yeah, it's like a Mapreduce. Okay, the programming model is a Mapreduce. Okay, right. So these important 2 things you have to understand. One thing is it's like a distributed storage, and it's like a processing with Mapreduce programming model on cluster of commodity hardware. Already I said that it's like a cluster. What is cluster? This is more than one system joined together. So that's actually a cluster. Okay, of commodity hardware. So commodity hardware in the sense industry standard hardware. So whatever the laptops you are using it, or it's like general desktops. Okay, so the desktop which costs for 15,000, 20,000 like that and all. So that commodity hardware. This is the important advantage of using the hardware. This particular Hadoop and all. Okay, it doesn't in the earlier the traditional system Oracle or something, you have to keep it only on the servers only. Okay, what is the difference between server and usual system in the sense? Okay, servers will work in a different way. Okay, and before that, I'll just explain what is cores and other thing. If you already people about thing and all, not an issue. If it's like additional information I'm giving. If people already don't know, okay, just I'm giving about the hardware configuration and all. Okay, so generally the processors will be we can say processor. We'll say microprocessor will be having 2 processor, 2 CPUs. We'll say 2 CPUs, 3 CPUs and all. Other way we can say that cores. Okay, core in the sense that's what. Okay, for example, if you are using a i3 laptop, okay, i3 in the sense Intel i3, that will be having 2 cores. Okay, so 2 cores in the sense it is like a 2 processors. It is having two processors. You can run 2 processors parallelly. Okay, that's why actually your system is working a bit fast. When you are trying to work multiple work and all. Okay, so the one core is working on different part, other core is working on different part. Okay, and if you are having some 4GB, what is that? i3 with 4 GB of RAM. Okay, each core will share the RAM. Okay, based on it won't share exactly. This core will share 2 GB. This will share 2 GB. It won't like that. Okay, but it shares the RAM and all. In case both are working in parallel, so this will share some 2 GB. The other core will share some 2 GB. Like it will work. Your i5 will be having 4 cores. Okay, i5 from 8th generation. It will be having 4 cores. Your i7 will be having 6 cores. Okay, that's the reason. So what is the difference between i3 and i7? i3 is having only 2 core, i7 is having 6 cores. Okay, your i7 will work 3 times faster and also 3 times more work. You have to say 3 times more only, you have to say, not just like a faster. 3 times more work than comparing with i3, because 6 different works you can do it with your i7. So sometimes if you are running some Oracle on the background, one core will work on that Oracle, and some model building is running on other core, that will be one core will do. Another thing, if you are watching some movies or searching something, one core will do like that. Okay, so multiple things will be working. Okay, that's what actually the core and all. Okay, so always I'm giving a suggestion when you're going to buy a laptop or looking at the hardware. Don't look at only the i3 or i5 or i7 or whatever it is and all. Just read that how many cores it is having. Sometimes you might be getting some laptop, they'll say that i5 is coming very less cost and all. Just look at that. It will be a 7th generation. The clocks, the frequency to start with i5 with 7,300 or 7,500 something, it will be coming. That means it is 7th generation. If it is start with 8,250, 8,500 in the sense, it's like 8th generation. If it is coming as a 9 in the sense, 9th generation. You look into that one. Okay. Sometimes the i5 7th generation will be having only 2 cores. Though it's like i5, it will be having only 2 cores. Okay. Instead of that, you can go with i3 itself. Okay. Nothing. Only the clock speed increase. Otherwise, only you will be having only 2 cores. To use only 2 cores, why you have to go for i5? Okay. Anyway, it will work in 2 maximum. You can work 2 works only with i5, that 2 cores and all. Okay, that's what you have to understand. Okay, right. So this we are generally we are using this i3, i5. That's what we know. But when you are going for industry hardware and all, they will buying itself. They are saying that it's like a 4-core machine, 8-core machine. Okay, 8-core in the sense. How we are defining it's like i3, i5 like that. So 8-core in the sense, it's like that machine is having some processor. We don't know what is the processor, or Intel or Acer or a different company. We don't know what is the processor, but the company is having that particular hardware. But no, it is having 4-core or 8-core. Okay, that's what. Okay, so when I'm talking about the server, when you want to compare with what is the normal product and the other server. Yeah, I'll come to you next. Definitely. Okay, we have actually a separate slide for Mapreduce. Sure. Okay, right. So in the server in the sense, generally they will go with 16 core and 18 core. Okay. Okay, 16 core, 18 core. 16 core, 32 core, 64 core like that. Okay, and also the server, you have to keep it. You cannot keep it normal floor and all. So you have to keep it on proper place and all. The temperature will be around 0 to 5 degree. Yeah, what do? You read about that one. Okay, when you are looking at the configuration, okay, your laptop configuration or something, they will say that i3. They don't say only i3. Okay, and also they will say i3 5300 like that. They will mention i3 5300 or i5 7300. And 7 after 7 any number can come. 4 digit actually it will come a 4 digit. Okay, i7 8750 like that it will become. So that particular model, okay, you search for, okay, and it will say that whether it is having for 2 cores or 4 cores or 6 cores. They will mention in the Intel site itself. Okay, or also you search in the Google, it will provide. Fine. So that's what actually having. And also the maintaining the server, you have to keep it on separate server room. So you have to maintain the temperature between 0 to 5 degree, and also it should be very cleanliness. All those things will be there. So that's the thing. So in case if you want to have store some huge storage and all, you have to go for 2 or 3 servers. Okay, and you have to keep it in somewhere. But the server hardware all, it's like a very high end. Like you will get good support, good durability. Okay, that's the reason. But for example, normal desktop, okay, you run it for longer time, it may hang. Okay, sometimes it will shut down. Even your laptop also, people are facing a lot of problems. You might have been facing a lot of problems. Okay, if you are running something, if you didn't shut down for at least 1 day, 1.5 day, if you are doing something and all, so it will hang or it will provide something. You have to restart and all. Okay, but the server, those kind of problems would come. So server restarting is an it's a news. But our laptops, others, sometimes if you are restarting, that's a regular task. If you want to restart a server in this, that should be a news, and so you have to publish. Inside the company, okay, if you are restarting a server, you have to inform, and it will be talking about. So many people are talking about the server is restarting like that. So that much actually huge thing. Okay, that's what on the server. But this is actually commodity hardware is our normal commodity hardware. What is the difference between the sense? A basic server generally it will cost for at least 30 lakhs. Basic configuration, I'm saying, like some 16 core, 64 GB RAM, and some 20 TB hard disk, a 20 TB hard disk, and other configuration, network card, and other thing. And a basic server will cost for 30 lakhs. Okay, but our basic desktop will cost for 20,000. That's what. So in case if it is like I'm saying, it's like a 20 TB. Yeah, if you want to store around 10 TB and all, you go for basic server, invest 30 lakhs, okay, and you can go for server. In case your data is coming for 100 TB, you are thinking that your company data, I am going to handle 100 TB. So actually go for like 5 servers. Okay, so 5 servers will come for 1.5 crore, 1.5 crores and all. Okay, so same way. That's what actually when you are maintaining with server, it is a costly, but Hadoop is running on you can install Hadoop on commodity hardware. Then you just compare like how huge cost effective it will be. Yeah, server will cost for 30 lakhs, but in a single desktop will cost for 20,000. Okay, maybe that desktop it is going for storage part itself, I'm saying, so that 2 TB capacity you are having it. Okay, so 10 systems. Okay, if you all together, if you add a 10 system on the cluster, okay, so overall you will be having a 20 TB capacity. You will be having it. But what is the cost? It is a 2 lakhs. Okay, but to get a 20 TB basic server, it will cost for 30 lakhs. Okay, see the huge cost difference. So this is the one of the reason. Many people actually, they were switching into Hadoop. I'm talking about early 2010s, okay, around 2010 and all. The people are very keen on switching into Hadoop is because of this reason only, because Hadoop can run on cluster of commodity hardware. That is the important thing. Okay, so once again I repeat, Hadoop is an open source, so that no doubt at all, so nothing is needed, but we are using for distributed storage. So distributed storage, I mentioned it's like add multiple system into one cluster, so that you can store your data distributedly. Okay, so all together virtually you have to think it as a one single system. Okay, and you can store huge data, and also you can process it with the Mapreduce. Okay, if you want to analyze it, if you want to some query, or if you want to process the data, whatever it is, okay, you can use the Mapreduce programming model, and the Hadoop you can install on the cluster of commodity hardware. Okay.
Sorry, one question here, yeah. So I mean, does Hadoop store automatically store the copy of the data like MongoDB?
I couldn't get you.
The Hadoop also stores a copy of the data automatically, or you have to do?
Yes. No, actually, just I was giving the overview about only. But when you are getting into this next level partner, you can easily understand how actually it stores and all. Okay. Next, in few slides, actually, you'll get clarity about it. Okay. Fine. Yeah. Right. So here actually we have seen this main is functionality of Hadoop. This distributed storage and using of Mapreduce is a functionality of Hadoop and all. Okay, and before getting into this, before deep digging into this functionality, we'll just physical architecture. Okay, what is the physical architecture of Hadoop? Then we'll see what is actually HDFS and then what is actually Mapreduce and all. We can see like. So physical architecture in the sense we can see this part. First we can see this part, okay, and we will come for this distributed storage and Mapreduce and all. Right. Generally, okay, in any architecture, Okay, high level, any software or any tools and all, it requires an physical architecture. Okay, physical architecture is required. For example, how many systems you are having it. Okay, in a cluster. So if you say that it's a cluster, and how many systems are there in the systems, which is the master or which is the slaves or which is the master server client architect, client server architecture, you might have heard about it, client server architecture. So what is the server? What is the client? Okay, where actually what server handles the data, or what is the functionality of server, what is the functionality of the clients. Okay, this is a high level architectures will be there. The same like, okay, it's like physical architecture is, we can just see Hadoop is having a master slave architectures. Okay, master slave architecture. If there is if overall the entire this is a Hadoop cluster. Okay, we can say this is the Hadoop cluster. Inside the Hadoop cluster, okay, so it's like the Hadoop architecture will be a master slave architecture. That means one master machine will be there. Okay, the physically one master machine, and lot of slaves will be there. Lot of slaves will be there. This is the actual physical architecture of Hadoop. Okay, fine. This is the master server. So this is a master and this is a commodity. This one. So while setting up a Hadoop architecture, so we have to say this master always should be a very high-end machine. This should be a server. Okay, this should be like high-end, this 30 lakhs machine or whatever it is, like those kind of machine. This should be there. Okay, it should be very high-end machine. These slaves can be a normal commodity hardware. Okay, this can be like our like a 20,000 desktop. Just I'm saying that normal. Okay. This is the physical architecture. So one master, lot of slaves will be there. Is it fine? It's like a master slave architecture. It will be having it.
Hi.
Yeah.
Hello. Yeah, your master slave architecture you are telling means there is one system which is the host systems and the server is hosted over there, and the other systems we are connected to that and we are working.
Yes, that's right. Okay, all these slaves and all connected to this master. All these slaves are connected to each other. Okay, they are connected to each other. Okay, and also all together they are connected to here also, to the server.
Yeah, thanks.
Okay. So this is actually master slave architecture. This is a high-end server, and this is a commodity hardware. Okay, fine. So you understand, okay, what is master slave architecture? Am I right? Right. Next, actually,
hi.
Yeah.
You say it is a master and slave architecture, and master is some
high-end machine, high-end server.
So if the server goes down, then what happens?
Yeah, that actually Hadoop is having its own functionality to handle in case if server goes down, what can happen. It is having its own functionality. Okay, but it's like a later stage. We are having like how it is handling it. Okay.
Yeah.
Fine. Got it? Right. So you understand this master and slave architecture. So this is actually physical architecture. Next, actually, we can see into the storage part. Okay. So here actually we have seen, it's like some 4 important keywords and in a cluster of commodity hardware. Okay. So I answered here, this particular point with the physical architecture. Okay. So it's like we are having only one server, but we are having multiple slaves. It's the thing. So already I said, and in case if you are using a traditional system, if you need a huge capacity, everything should be a server. Okay, all should be the server. But here actually we are using only one server. But based on our capacity, we can add more this particular commodity hardware and all, so that our cost will be reduced and all. This is the thing. And after that, next actually we can see important Hadoop functionalities. Okay. In other way, hereafter I'll say important. Hadoop is having 2 major functionalities. One is storage, second is processing. Okay, one is storage, second is processing. First, we can see more detail about this storage part, and next we can see about the processing part. Okay, storage part is managed by this Hadoop distributed file system. Okay, that's what actually HDFS we can call it as Hadoop distributed file system. That's what actually the storage part. Okay, this one actually Google's distributed file system will be there. Google developed this distributed file system DFS. Okay, based on that paper only, they developed actually the Docketing, and their team developed it. And when they named the product as a Hadoop, okay, they added Hadoop inside. So Hadoop distributed file system, it's like a HDFS they are mentioning. Okay, that's what actually Hadoop distributed file system. Fine. This one. Here we have to understand distributed file system. Okay, it's like a distributed file system. That's the important keyword here. Okay, so you don't imagine like the data are stored in a way how the traditional systems are storing. Okay, maybe if you are using an Oracle, you will be storing only structured data. Okay, like you create tables, and tables having multiple columns. So based on the tables, you send the data. Oracle is storing it. But it is not storing in any other data format system. It is storing as a file system. Okay, file. How you are having a Windows file system or Unix file system, whatever it is, Mac or whatever it is you are using it. How you are storing your data? You are storing it in your Windows file system. Okay, so you have data structure. I mean, like a direct structures, right? If you look into this PC, you are having file system. So I'm having 2 drives, C drive and 2 drive. Okay, under this D drive, if you get into this C drive, different folders are there. Okay, and inside the folder, subfolders, files will be there. Okay, and what kind of files you are storing it? Any kind of file. Okay, audio file, video file, documents. Okay, Excel, Word, everything you are different things you are storing it. Okay, the same way only Hadoop also, it's like a file system. Okay, it won't store the data in a structured way. It will store the data in the form of files only. Okay, if it is like you are having some transaction data, 10 years transaction data. Okay, so in some structured format. So if you are moving into a file, what kind of file you can use it? You can use a CSV format or Excel file, or it's like a TSV format or something and all. You store that file into HDFS. Okay, so yeah, anything stored in this HDFS will be stored in the form of file only. It won't store as any form of data, or it's like direct table or something or nothing. It will be stored in the form of files only. How your Windows file system you are storing your data, like that only this will be storing. Okay, that's what actually using this distributed file system. That later I will explain actually how this distributed file system is storing it up. Okay. Right. So this is actually HDFS. Once again, I'm repeating, this distributed file system developed by Google distributed file system. From that, this Docketing team developed it, and they named it as a Hadoop distributed file system. In case if you are using a Google Cloud Platform, GCP, okay, there this Google DFS is available. If you are planning your company's architecture, if you want to deal with some big data and you are implementing your tools on GCP, in GCP you won't get this HDFS. Okay, in GCP you will get their own DFS only. Google distributed file systems will be there. But as a separated tool, if you are using Hadoop, I mean like Hadoop tool on your own, okay, we can go for this HDFS. So keep in mind, storage part is handled by HDFS, and the processing part is taken care by Mapreduce programming model. Okay, so Mapreduce, it's not a software, it's a programming model. Okay, but Mapreduce is you have to work Mapreduce with the Java technology. Okay, Mapreduce is a programming model, but which technology you are using it? We are using Java technology. Java software only we are using it. Like how we are building it. If you want to build a model, you can. It's up to you to pick R or Python. Okay, R or Python or any other tools. It's up to you. So I mean, like you are going to build a model, you are going to analyze something, but which technology you are going to use is up to you, R or Python. So same like it's like a Mapreduce is building a model. Okay, it's like programming a model. This programming model we have to use only Java technology. Okay, so the processing will be taken care by this Mapreduce and this Java technology. I'll later, after seeing this SDFS, okay, I'll explain how Mapreduce is working and all. Okay, fine. So this is the two part and all. Right. Next, actually, earlier we have seen the physical architecture, and also now we can see the we did see the functionality, Hadoop functionality. Now all together we can see how it works, the physical architecture and this functionality, how it is working, we can see all together. Okay, so I already said it's like a master and slave architecture. Okay, generally in Windows, whenever you are using some Windows laptop, I'm just giving only the Windows laptop. Okay, in case if you are running some softwares, okay, how actually it is running in the form of services. Am I right? You just go Windows run services.msc. Just type services.msc. Okay, this is the thing. Every functionality is running in the form of service only. Any fax service or .NET or Java or so for antivirus Kaspersky is running. Everything is running in the form of services only. See, from here, if you can see my Kaspersky, my antivirus is running. Okay, yeah, just look at this antivirus. Yeah, it's fine. You are just looking at the front end window only. But in the background, how it is running in the form of services. Okay, this is the example. Okay, same way only any functionalities are running background in the form of services only. So I mean, like Hadoop can be installed only on Linux flavor only. We cannot install Hadoop on Windows. Windows won't support Hadoop. Okay, Hadoop you can install on the Linux flavor only. Okay, and if you people already working on Linux environment, you already know. If the people already didn't work on Linux, okay, you may get confused about so many things and all. I'll just give you. So Linux is an open source operating system, okay, but it is having different flavors and all. Okay, different flavors in the sense same because it's open source. Okay, so the source code is already available. Different people are taking. Okay, common functionality will be, I can say that 95 to 98% common functionality will be same only, but minor differences will be there for different companies and all, different company. So that's why actually what are the different company, Red Hat Linux is there. That is the major player on Linux. Okay, Red Hat, Ubuntu, CentOS. Okay, so this kind of Debian, different names you can care about it. Okay, don't get confused when you are reading about it. Anyway, after this, from tomorrow onwards, we are going to use this Ubuntu only. For the work on Hadoop and Spark, we are going to use Ubuntu. I mean, like some Linux environment only. So this Linux, actually which Linux environment we are going to work is actually Ubuntu. Okay, that's what I'm saying. Linux in the sense, it's an open source. Ubuntu is a different company. CentOS, CentOS. CentOS is a different company. Debian is a different company. Red Hat is different company. It's up to you. Whichever you like, you can take it. It doesn't matter. Okay, somebody say that I'm working on Ubuntu. I'm working on CentOS. Somebody is saying. So don't get confused and all. So you both are working on same kind of code only. 98% of functionality same only. Something minor differences will be there. Other than that, nothing will be there. Okay, that's what. So we are going to use the Ubuntu environment. No, we can't. Okay, it supports only Linux environment. Hadoop supports only Linux. Okay, right. So already I said in Windows, everything is running on in the form of services. Okay, in the form of services. Okay, but in Ubuntu, same services only running, but we have to call that name as a daemons. Okay. Daemons. Daemon or daemons, service, okay, daemons. So in Ubuntu Linux flavor, it's like a daemon. In Windows, actually, it's like a services. Okay, anything we can call it as. So hereafter, I will be calling as a daemon only. Okay, like the same way. I already explained, like even for Kaspersky also, we are looking into this front end as a some front-end window only, but in the backend it is running as some services it is running. For Kaspersky itself, some 4 or 5 services running on different backend. Same like just, I'm opening this PDF, the front-end window, we are looking at this PDF viewer, but if you look into the background, actually this Adobe is running in some services like that only. The same way, so anything, any tools or tools or software will be running in the form of services or daemons in the background. Okay, right. If you see this storage part, this HDFS, okay, to handle this, there are 2 daemons running to handle this storage part. Okay, 2 daemons. In the other form, we can say 2 services. Okay, one is called actually name node is running on the master, and data node is running on the all the slaves. Okay, these 2 daemons or these 2 services are actually taking care of the storage part. Okay, so name node and this data node. The same way, the processing part will be taken care by resource manager and node manager. This resource manager daemon is running on master, and the node manager is running on every slaves and all. How actually it is work in the sense, I'll just give one example. This service is running. What this will do, this data node will send a heartbeat signal to this name node. Okay, heartbeat signal. So the basic interval is actually 3 seconds. Every 3 seconds, okay, it will give a signal to the name node that I'm alive, I'm alive, I'm alive, I'm alive. Not only this name node. So in case, for example, I'm having this three slaves, we are having it. Generally, you will be having 30 node, 50 node. Okay, and 50 node, 30 node is commonly, 30 to 50 node is commonly using. If it is like a 100 node cluster in the sense, it's like a bigger one. We have to say some bigger companies are using 100 node cluster in the sense. Okay, hereafter node, here I am saying NODE, node in the sense, it's a machine. Okay, we have to say that it's like a machine. Okay, so instead of I'm saying this slave machine, I say this as a slave node. Instead of master machine, I'll say this as a master node. Okay, this is the way actually we have to. I'm speaking in the form of Linux language. Okay, that's the way. So it's like a node. This is a master node. This is a slave node. Okay, physically I'm saying master machine. Instead of master machine, I'm saying master node. Physical machine, I'm saying it's like a slave node. Okay, inside this server, service. The service name is data node and name node. Okay, fine. So if you have the 100 node cluster, every data node, okay, every data node is running on a slave, will send a heartbeat signal to this name node, and it will say that I'm alive, I'm alive, I'm alive. Okay, along with this heartbeat signal, it will send so many information. What are the other information I'll say later, but as of now, you understand that, okay, it is saying that heartbeat signal. So that name node is taking care, okay, how many is running, how many is, if it is not sending the signal, it will wait for another 3 times or some 5 times waiting for signal. After that, if this is not sending any signal, this name node will say that this particular machine is down. It mark as this particular machine is down. Like that, it will mark it. Okay, this is actually it is storing it. And one important thing is that this master node will not store any data at all. All the data will be stored on slave nodes only. Okay, all the data will be stored on slave nodes only. Then what is the work of the name node? This master node won't do, just it will control the slaves. Okay, it won't store anything at all. Okay, that's where actually this might be having, for example, I'm saying 2 TB hard disk, 2 and all, so overall capacity is 6 TB. Okay, so when a new data comes, okay, data will be stored. Okay, and this data node, when sending the heartbeat signal, and also say that what is my storage capacity, how much already I store, okay, and what is this free space. Okay, those information also will send to name node along with the heartbeat signal. So that it's like I'm saying a 3-second interval. Am I right? So the name node will have the up-to-date information about, okay, each node is having what is the storage capacity, what is the free, okay, and all those information that will be having. Okay, so with this functionality only, okay, the storage part is now taken care by this Hadoop. Okay, once again I repeat, the storage part taken care by 2 daemon, name node from master, data node from slave. Okay, and name node won't store anything and all. Okay, everything will be stored on slave nodes only. But the data node will keep the information and send to the name node. Name node just will control it. Okay. Same way only the processing part, resource manager and node manager will be there. Okay. This node manager will taken care of the resources. Okay. This data node will taken care of the storage part. What is the capacity? How much stored? Okay. All those information data. But this node manager will have the resources. Hereafter, if we talking about hardware or in the cluster resources in the sense, okay, so what all the resources will be there in a machine? I'm saying the processor. Okay, I already said the processor might be having how many cores the processor having, what is the RAM. Okay, so those kind of information it will be having. So if this machine is having 8 core and 16 GB RAM, for example, so each slave node is having 8 core processor, 16 GB RAM. That means that 8 core and 16 GB. So approximately each core will share 2 GB of RAM. Okay. Then this node manager will say that in the 8 core, no work is running here. Okay. It will say that all 8 cores are free, all 16 GBs are free. In case here, you built a one model. If that model is running on this particular machine, so that is using 1 core and 2 GB of RAM. Then this node manager will say that I'm having 8 cores. So 1 core is already used. And 2 GB RAM is already used. 7 cores and 14 GB RAM is free. Okay, that information it will give to the resource manager along with the heartbeat signal, so that this resource manager will be having up-to-date information about all the machines. Okay, I mean like every individual machine is what all the resources are there, what all the resources already used, how much it is free. All those information will be taken care by this resource manager. Okay. So this is actually we are seeing all together. It's like the physical architecture and also the functionality part with the usage of these daemons and all. Yeah. So you people, if you have any doubts or a clarification, you can ask me, or else if you are not able to understand, if you ask me, I can repeat once again. Oh, okay. So I understand that actually you people understand this, Hadoop part and all. So anytime actually, if you have any doubts about,
I have a quick question here. Is it possible for clusters to interact among themselves?
Pardon?
Two clusters.
Yeah.
Two clusters, can they interact? Like, is it possible for them to
Yeah. See, whatever I explained here, okay, this is what actually, okay, this is what, okay, one master, okay, one master we are having, okay, master and slave. So this is storage for data node, name node. This is resource manager name node. Okay, the entire thing is like this only. Okay. Yeah, actually, we cannot go here. The entire cluster is like a wall. Okay. So actually, our machine. Okay. So for example, if it is you are here. If you want to store some data, okay, you cannot store here. Okay, you have to access this cluster. How you have to access this cluster in the sense, first, when you are accessing the cluster, so straight away it will take you to this name node only. Sorry. Okay, it will take you to name node only. It will take you to the master node. Okay, then the master node will instruct. Okay, instruct, and then only it will store. That's what actually you have to approach the cluster, and the cluster security will be there, and the cluster will instruct. That will send your request to here, and then only it will be storing here.
Okay, so this is one cluster. Say for example, we have another cluster. What I'm asking, some in way, say for example, the data is all related, and for some analysis, and is it possible to get the data from more than one clusters and combine them and use it? Is it possible?
Yeah. Because see, from here, I'm talking about storage part. Okay, if you want to get some data from here, the same request only. The same request will go to here, and which data is needed. Okay, it will give it to you. Okay, so where you will process it in your local machine only. Am I right? Yeah, you can combine it, not an issue. But not in the inside the cluster, but outside the cluster. If you're having another cluster from here, for example, cluster 2, you take the data, combine outside of both cluster, and you have to do it. But practically there won't be any more than one cluster. Okay, in practically there won't
So
be
in projects, they won't use more than one cluster for storing same set.
Not in project. In practically, I'm saying in the industry, because this Hadoop is having the like that much of flexibility. Okay, so one cluster itself, I'm saying you can go for 100 node cluster. Okay, that will be more than enough. Okay. Even if you are thinking that more data is coming, you add more machines. That's it.
Okay, yeah, thank you.
Fine. Yeah. So next, actually, we can see about Hadoop key characteristics. Okay. Yeah. So we will look into this key characteristic. I think this will occupy the today. Most probably we'll stop with this slide only. Okay. You can see that it's like a single slide, but it will take a lot of time to explain. Okay. These are all the Hadoop key characteristics. Okay. What is that? We can say that it's like economical, scalable, okay, flexible and reliable. These are all the key characteristics. So already we said it's like a one thing. It's like we are using commodity hardware, so that the people are keen to move into this big data environment. That's what I said. Okay, that's what. So first, we see one by one. This is actually economical. Economical already we said. So it's like we can use industry standard hardware. Okay, I'll explain just once again. In a different example. For example, you are using some traditional system, okay, maybe Oracle or something. You are having a capacity of 20 TB. Okay, you already bought a basic server. It is having, I'm saying, like a 16 core. I'm saying it's like a 16 core and it's like a 32 GB RAM. I'm just saying, I'll write it. Okay, you bought an Oracle server. Okay, that is having 16 cores. Okay, and 64 GB RAM. 64 GB RAM. Other things and all I'm not saying. Just I'm just talking about only this part only. Okay, it's like a server. A server. This one actually. Okay, and what is the storage? It's like a 20 TB storage. 20 TB HDD. Okay. This, while buying time, you thought that we are going to use only around less than 10 TB of data only. But anyway, for some other reason, you gone for this 20 TB and all. But after using years, and it is reaching 20 TB. Okay, what we can do? 20 TB, and earlier you thought that it will be around 10 TB of data only. Okay, when it is reaching nearing 20 TB. Okay, one thing is you are feeling that it's about to full. What kind of action we need to take it? Other thing, when you are having only the 10 TB of data with this resource, 16 core and 64 GB RAM, actually it is working fast. Okay, but when it is reaching this, for example, if it reaches 19 GB already, but because of this huge data, this resources is not able to handle this. Your system is getting slow. Comparing with when you are having 10 TB of data, it is getting slow. So at that time, okay, what we will do? Okay, we can do a scaling. First option, we will do a scaling. Okay, so scaling in the sense, okay, it's like increasing or something. So here, what we will do? We will do a scaling up. Okay, scaling up in the sense when it is reaching 19 TB. First, you are not thinking about the storage and all. Because your machine is slow, what you will do? You will try to upgrade this machine. Okay, maybe this core up to some 32 core. You are saying this some 32 core you are upgrading. Okay, and also this also you are upgrading to some 128 GB RAM. 128 GB RAM. Okay, so you are upgrading, and also when it is reaching nearly 19. There is another option that your machine is providing. Another option, you can add another 5 TB hard disk. Okay, maybe additional provision is there. That is the maximum it is providing. So another 5 TB hard disk, you can add this. Okay, this one actually you are upgrading your machine. This means you are upgrading your machine. That's what actually we are scaling up. Okay, so upgrading. So this actually you have to say as a vertical scaling. Okay, vertical, because you are upgrading. So vertical scaling. Okay, vertical scaling. So vertical scaling in the sense scaling up or scaling down, anything you can do. So what is down in the sense, in case you are having 32B, in other case, you are having 32 cores, okay, that is actually too much. Okay, even 8 core is enough in the sense, you can reduce to 16 core. That is a downgrading based on situation. Okay, generally downgrading won't happen mostly, but upgrading will be happening. Okay, this is what actually vertical scaling, and or we have to say scaling up or vertical scaling. Okay, but after reaching entire thing, even you reached this 25 TB, what you have to go for? You have to go for another server only. So what is the cost actually? It is like a 30 lakhs. So you have to go for another 30 lakhs. Okay, that's what actually, that is the option actually we are having with the traditional systems. Okay, right. So you understand, am I right? Vertical scaling and other option. So the cost wise, when you are reaching the limit, if you want to go for expanding, so it's like the expansion will cost you more actually. Okay, cost you huge. We can say instead of more, it cost you huge. This is what. Okay. But here what we are doing actually here. So we are using one server. Okay. So as we are not going to use storage here. Okay. And also we are not doing any kind of work actually here, because this is going to control this server. So even the basic server rental, we can say that it's like a 10 lakh or 15 lakh something. Okay, we can say that, yeah, 15 lakhs. This cost is 15 lakhs. Okay, what is this cost of this machine? I'm just saying, like a 20,000. Okay, 20,000 with 4 machines, or if you are having 5 machines, it will cost for another 1 lakh. Okay, so within 60 lakh, you will be having some 10 TB of capacity. 10 TB of capacity. And another thing you have to understand the resource. Okay, I'll add one more message just so that you understand. Okay, just another 5 machines are there. Okay, if this is having 8 cores, I'm talking about 8 cores in the sense, overall we are having 40 cores. That's what we have to understand. Overall 40 cores. If each machine is having 16 GB, okay, so the overall it is like a 5 into 16, 80 GB RAM. So it's like a 40 cores and 80 GB RAM we are having. For what actually? It is like a for 16 lakh. So it's half of the amount when we are using the traditional system. Okay, that's what actually here it is calling as an economical. Okay, so this one.
Hello.
Yeah.
You are telling that in each system we are storing the data. Data is stored in the slave systems. In the slave systems, data are stored, right?
Yeah.
But if the slave system, master system is having more memory, and the slave system is having less memory, will store so huge data in our slave system. It won't get. It will be slow. Process will be.
No. It won't slow. It won't slow. Because the Hadoop processing and storage, Hadoop's resource usage policy is completely different. Okay, give me 10 minutes. Okay, the next when you are coming reliable, actually you will get the information. Okay.
Yeah,
fine. So this is actually economical part we are allocating. Next, actually, it is like a scalable. Okay, the scalable, just what I mentioned here. So actually here server, traditional server, we are using this one. Vertical scaling we are using. Now I'm coming for Hadoop. Okay, Hadoop, what is the advantage of Hadoop in the sense? Okay, one master only. One master will be there and multiple slaves will be there. Hadoop is having the capability to add more slaves, okay, with very ease. Very ease. Okay, so I'm having 5 node cluster. So it's like each is having 2 TB. It's like my overall capacity is 10 TB. Okay, so in case if it is reaching the limit, so already it is reaching 10, but you are thinking that another 5 TB of data will come. What you do? So if you add 3 more machines, okay, it will be easy. Another 6 TB you are increasing your capacity. So that adding that another 3 machines, okay, you have to buy. That's it. After buying, after adding into the network, setting up will take less than physical, I mean, like in case if we are maintaining our own Hadoop system, less than half an hour, I think, we can add 3 machines into the cluster after putting it in the network, okay, and doing some programming and other thing, just pushing this after, within half an hour we can add 3 messages. I'm talking about physical thing and all. In case if you are using cloud environment, okay, like within minute actually you can add or remove machines. In AWS, GCP, or any other cloud environment if you are using, okay, with the capacity, I mean, like it's a complete administration part and all. We don't want to get into that one, but you have to understand one thing and all. Within minute, any number of machines you can add or also remove. Okay, that's what. So you can add more slaves into the cluster. Okay, that's actually we are like scaling out. Scaling out. That's what I mean. Okay. Otherwise, we can say it is like a horizontal scaling. This one. Okay. It's like a scaling out or scaling in. If you want to add machine, that means scaling out. You are adding more machines and all. So scaling in the sense, it's like you are thinking you've gone with 50 node cluster. Okay, you are expecting some huge data, but after running 6 months and not that much data is coming and all. Even 10 node is enough. You are thinking that. What you can do? So okay, you keep another 10 nodes. So overall 20 nodes, 30 nodes you can remove it. Okay, that's what actually having. So that kind of scalable. Okay, that kind of scalable feature is Hadoop is having. One example I will say that it's like a 10 years before when Sachin Tendulkar was hitting the first double century on one day. Okay, this Cricinfo site. Okay, this Cricinfo site actually they are running. So usually everyone will be having that based on their customers. They will have some buffer limit in case if it's like 1 lakh people actually watching. If they are thinking that, so another 20% they will be having a buffer. Okay, so maximum 1,20,000 users can use that one. Okay, but when he's reaching 190, what happened? The Cricinfo site was gone. Okay, for I think nearly less than 5 minutes. Nearly 5 minutes it's gone. The site is not working because the number of users increased more than that limit. Okay, but within 5 minutes actually the site was up. Okay, at the time we didn't know, but after learning big data only I came to know that actually even that time also this Cricinfo site started using big data technologies. Okay, within 5 minutes they added machines into the cluster and it was up. I'm talking about 10 years before. 10 years before, within 5 minutes, we don't know how much machines they have added and all those technical information we don't know. Okay, but we know that within that 5 minutes they added machines into the cluster and they restarted so that the site was up. Even with the more number of attempts at that time, more number of users. Okay, that kind of flexible. I'm talking about 10 years before. Now and all, it's like within 1 minute you can use it. And also in Amazon AWS you are having auto scaling. If you set it up auto scaling, based on it, automatically it will add or remove machines into that one. Okay, in case you are launching some news website or something. Okay, sometimes suddenly the people are coming, more people are coming, automatically add into the machine without any hurdle. Once the number of people are going out, okay, it will remove the machines from the cluster. Auto scaling based on that. Okay, those kind of facilities we are having it as of now. Okay, right. So this actually Hadoop is having scaling in, so scaling out. So that's actually horizontal scaling and all. Okay, right. These are scalable. Next, actually flexible. Okay, so the flexible in the sense that's what I said in an example. So if you want to add, you add. Otherwise, you remove it. Okay, so that kind of flexibility it is having it. So one example I can say some government shop is having. So nine months you can see. So they can run with some 10 TB of data. If that's a government shop and all. Okay, but during Diwali time, what will happen? So more data they need to add. So generally, if they don't go for Hadoop and all, comparing with the 3 months, always they have to keep the entire. So for example, their capacity is 10 TB generally for 9 months. Okay, but during Diwali time, 15 TB of data only there. But for that particular time, all 15 TB, their infrastructure should have 15 TB. But only 3 months will be used. Rest of the time, the other 5 TB we are not going to use. If they are using Hadoop, general then you use it. Okay, when Diwali time come, you add 3 machines into your cluster. Once the season over, you remove that. Okay, because nowadays no one is using physical. Okay, most of the people are using cloud only. Okay, they are not using their own Hadoop cluster. Okay, they are using the cloud only. So in the cloud, how many machines you are using, based on that only you are going to pay the rent. You are going to pay during that time. Add 3 machines, you pay additional. Once the season is go, just remove it. Okay, you don't need to pay for that particular 3 machines cost for another 9 months. Okay, that kind of flexibility it is having it. Yeah. So these three actually it is easy to understand. It's like economical, cost way, scalable. So it's like a horizontal scaling. You can go for horizontal scaling, scaling in, scaling out, and the flexibility. That's what the flexibility we are having it. Next, actually the reliability. Okay. We already said we are using industry standard hardware. I mean commodity hardware as a slaves. Okay. Just imagine how many, most of the people you have come across this problem. If some machine is running for more in your office, some desktop is running for 2-3 days continuously, it will hang or it will go down. There's a high possibility. In this Hadoop, in a cluster, can we switch off machine for some time so that it can take a rest or something? We cannot do. It has to run all the time. If there is a cluster, it has to run all the time. So that is the important thing. And when the things are running continuously, there is a high chance that some machine will go down. Right? Some machine will go down. So then what is the reliability? Okay, then what is the if this machine is going down, then what is the reliability, or what about the data here in this particular machine? Okay, we can restart it. We can restart it. That's a fine. But but you are doing some important work. But this machine is done. This data is important. Then what will happen? Okay, that's that issue is there. Okay, that how Hadoop is handling this reliability. Okay, before getting into this one, another important thing we have to understand. Okay. Okay, and I'll add one server. Okay, and multiple masters. So I'll just say 5 node cluster. Just I'm putting approximately. Okay, this is storage part like that. Okay, this storage part. Okay, and this is the name node. Okay, name node this case. So name node is taken care by the storage part is taken care by this name node, and data node is running. Okay, that's what. So here now we are coming into the important point of distributed file system. Okay, earlier I explained that distributed file system in the sense, so once this is full and the data will be here, so all together data will be different format, different systems. Okay, but Hadoop is storing the data in a different way. Hadoop stores the data in the form of blocks only, in the form of blocks. Okay, so this is data node. You just imagine this is the entire storage area. Okay, this is the entire storage area. Okay, so blocks in the sense, okay, it won't store the file as it is. Okay, so for example, if you are storing a movie file into your Windows laptop in some folder and all, just go there. Yeah, the movie file, entire file will be there. Okay, same way if you store any other document, any other file and all, you just go there, entire file will be there. Okay, but here it won't store the file as it is. It will break the files into multiple blocks. Okay, and the blocks will be stored. So that's the important thing. Okay, for example, what is the block size is, default block size is 128 MB. Okay. I'll share this notepad also in the okay. Default block size is 128 MB. Okay, 128 MB. This is the default size. Okay, right. Yeah. Before getting into this block, so just imagine you are having some 1 GB file and you have written some program to analyze it. Okay, and it is taking like 1 minute. 1 GB file to process it, it is taking 1 minute. For example, let's say. Okay, with your in case your file size is 10 GB. Okay, how much time it will take? Definitely it will take 10 GB. I'm talking about traditional system. Okay, yeah, it will take, because the data is huge. Okay, data is huge and the same resources you are using, so it will be like 10 GB of 10 minutes it will take. For 10 GB file it will take 10 minutes. When your file size is more, it will take more time. Even just imagine if you open a notepad, for opening a notepad file, or else same notepad file you open on the Word, how much time it is taking? You just store this file as a TXT. You just open the notepad. Okay, some second, maybe some fraction of second it will take. Same, you open a Word document, how much time it will taking? The same content only. If you open this file through Word, it will taking more time, because that's a heavyweight tool. Okay, so same way. So whenever even like when you are opening a PDF file or something, small file will open very fast. Okay, in case if you are having some 10,000 page PDF file, if you open it, definitely it will take a lot of time. Okay, same like only when you are processing anything. Okay, based on your file size, the processing time will differ. Okay, to overcome that only, actually the Hadoop is using in the form of blocks. Okay, right. So the default block size is 128 MB. What it means? Okay, if it is like a if 1 GB file will be broken into how many blocks it may come? 8 blocks. 8 blocks of 128 MB. 8 blocks of 128 MB. This is what. So whatever the file size, okay, you are providing, okay, it will break your file into 128 MB blocks and it will store it. How it will store? In the sense, it will store in a distributed way. That is the important thing. Okay, for example, there is a one instead of 1 MB file, I am saying there is a 256 MB file. Okay, you are storing some file, 256 MB file. How many blocks it will come? So it will come for 2 blocks. Okay, the first block will be stored on. It won't store in order manner. It won't store in order manner. So this is actually so this is the data blocks. Okay, the first block will be stored here. Okay, second block will be stored here. It will like that only. So this is the actual distributed way Hadoop is storing the data. Okay, the first block will be here. The second block will be here. So you cannot decide where the blocks should be and all. It is Hadoop system will take care where the blocks will take care. The name node will decide. How the name node will decide? I already said this data node will send a heartbeat signal. Okay, the heartbeats, along with the heartbeat signal, it will say that what is the storage capacity, okay, and how many, which files, how many blocks I'm having it, all those information it will say. So it will store in a distributed way. So 2 TB, 2 TB, 2 TB in the sense, it won't do that. It's like this will be like 1 TB and this will be 100 MB, 100 MB. Okay, it will make it like an even. So more or less all the systems will be having equal capability only. Okay, equal capability. That one, it said actually there's an algorithm is there. Okay, that algorithm actually, if you are an administrator or if you are a pure Hadoop software developer, then only we have to understand it. That algorithm, it is having a lot of criteria, it is having it. Okay, not only it's a even, and also how many blocks, how to store, based on all those things only it will decide. Okay, right. So that we don't want to get into more that one, but you just understand that if there is a 256 MB file, it will break the files into two blocks. One will be here and another will be here. So like that only the Hadoop is storing. Okay. You understand the concept, am I right? So if not, you just ask me, then I'll go into the next thing.
But why it distributes in different nodes? Yeah, I mean, when you retrieve the data, so it comes fast, or what's the reason behind?
Yeah, that's the reason I said, just before I said, when your file size is increasing, your processing time will be more. It will take more time. Okay, but when you are breaking your file into multiple blocks, all blocks are same size only. Okay, if it is you are having 120 MB file. Okay, to process the file, it will taking 1 minute. Okay, but even if it's like 1 GB file or 1 TB file, 1 TB file will come for 8,000 blocks. Okay, but each block will be having only 120 MB size only. We are going to process with block wise only. So overall, it will take one minute only. When you are coming for processing part, I will explain. But your blocks will be on the same size. Okay, so that the processing time will be very less. That's the biggest advantage when you are using big data technologies. That's the reason actually when you are querying something in Amazon, even the 100 billion, billions of products are there, you are getting immediately. That's the reason. Got it?
Yeah.
Yeah, fine. Okay, so it's like a multiple blocks. It's storing it, right? So here, and another, the Hadoop is achieving this reliability using a replication factor. Okay, reliability to replication factor. Okay, the default factor is 3. Okay, default is 3. See, whatever I'm saying here, the default block size is 120 MB. Default factor is that whenever you install Hadoop, that will be the by default configuration. That actually you can change it. I've said that this is like 120 MB block. Okay, it's up to you. If you want to change it to 64 blocks, you can change it. If you want to change it to other 256 MB block, you can change it. That's based on the situation you get. But most of the people will be using default configuration only. Okay, right. So here the default factor is 3 in the sense. Okay, every data will be having 3 copies. 3 copies of the data will be there. Okay, so that means that this file is having 2 blocks in the sense. So I already said this is the first block. Okay, this is the first block. This is the second block. So this first block, the 1 copy is there. Okay, and the second copy might be here. Okay, and third copy might be here. Okay, so okay, third copy. Just imagine, okay, this color is first copy, this color is second copy, this color is third copy. Okay, so 3 copies of data will be here. The same like for this second block. Okay, so I'll make it a bit bigger to make it a big block. So this second copy, second block. Okay, third copy will be here. Okay, and the first copy will be here. Got it? This is actually one first block. Same file only first block. Okay, this is actually 2. Okay. So what you are having? You are having 3 copies of the file everywhere. So you have to think that you are looking for 10 TB capacity. Okay, you have to architect your cluster with 30 TB capacity because you are storing 10 TB in the sense because your 3 copies will be there. So that actually it will be 30 TB it will occupy. Okay, that means that it's like a 5 machine 2 TB and all. Okay, then you have to add another 10 more machines. So overall your cluster will be having 15 machines. Okay, that doesn't matter. Okay, 15 machine will cost for 3 lakhs. Okay, 3 lakhs only. Comparing with 30 lakhs, 50 lakhs, when I'm talking about 30 lakhs in the sense basic server only. Okay, but if you are going for average server, it will go for 50 to 60 lakhs. Okay, comparing with this 40 lakh, 50 lakhs and all, this 3 lakh doesn't matter. Okay, that's what. So you understand the reliability is achieved by the replication factor. That means that all your data will be having 3 copies. So 3 copies in the sense, in case this machine is gone down, no problem. This first copy, am I right? This first block, am I right? Another 2 copies already available. Okay, so you can use here. That's how actually we are achieving this reliability. Okay. Here I'll add now some more points here. Okay, this the blocks are stored here, and what is the how we can say that these blocks are stored here, these blocks are stored here in the sense actually the name node is having name node will be taking care. The name node daemon, right? The name node daemon will keep all the information about this block in the form of metadata. So we are we already said the data node will be sending the heartbeat signal. Okay, heartbeat signal along with heartbeat signal. What is the storage capacity? What is the free size? How many blocks are there? That belongs to which file? Whether it's a first copy or second copy. What all the information it is sending. Then what is the work of the name node? We haven't seen. Like we said that it is controlling this. Okay, how it is controlling in the sense? Okay, the name node is having all the information. Okay, in the form of metadata. In the form of metadata. Okay, so if this file name I'm saying this file 1. Okay, then what it will do? This file 1 it is having 2 blocks. Okay, then the 2 blocks in the sense the first block is having in the machine 3. Second block is in the first machine, third block in the fifth machine, and also second blocks are here. Okay, all those information will be taken care by this name node. Okay, in the form of metadata, it will keep all the information only on the RAM only. It won't store the data into any hard disk. It will be keeping all the information on the RAM only. Okay, that's the important thing. Why actually it is keeping in the RAM only? Because we already said big data is a huge. Okay, and if it's like in a real environment, lot of new data will be coming, retrieval will be coming, process, so many requests will be coming. Okay, well, if the informations are inside the RAM only, okay, it can immediately provide the information to the client. Okay. So name node is maintaining all this the file name and the block size in the form of metadata. Okay, and also it maintains the namespace. Okay, you have to understand one thing on the namespace. Linux namespace. Namespace equal to file system structure. File system structure. In Windows, what we are having? We are having C drive, D drive. Correct. So if you are storing some C drive, D drive, so under the drive, so you are having folder, subfolder, files and all, so that in case if somebody is asking, yeah, it is there in the D drive in the particular folder, the file is there, you can say that. But in Linux, there is no drive. Okay, it is having in the form of namespace. Okay, straight away it will be starting the folder only. There won't be any drive. Okay, so for example, this is the Hadoop system, in the sense Hadoop. Okay, so this is actually a file. After this root, this is we call it as a root directory. This is the file under this Hadoop folder, and maybe this Spark class, this folder. Okay, some sample.txt file is there. Okay, this is the structure. This is how actually it will be in Hadoop. So don't get confused about what is the namespace in the sense. Namespace is actually a file system structure. Okay, so Linux won't have any drive, so straight away it will be. So this is the, from the root, this is the top folder. Okay, but if you look into this, if you look into this PC, actually there is no top folder. This is the drive. After the drive, Okay, we are having, this is the top level folder, and inside this, okay, we'll be having a lot of subfolders like that. But in Linux, we don't have any drive. Straight away drive and file system only. So this name node will have the namespace, because in the Hadoop, it is storing it. Internally, it is storing it in the form of this way. Okay, but no, we have to look at it in the way that while storing in the Hadoop, we have to specify in the folder format only. Say, even I'm in the Windows also, I'm just asking, you are saving a file, and the file, you know that, yeah, in the D drive, in somewhere you are storing, you know only that only. But in the background, how it is storing, do you know? In binary format, in binary, in this, how it is storing, do we know? We don't know. Okay, as an end user point of view, yeah, the file is there in the D drive or something like that only. The same way, if you look into this end user point of view, accessing the Hadoop cluster, yeah, so if you want to store some file, what you have to do, you create a folder inside the Hadoop. Under the folder, okay, you specify that file. That's it. You copy into that one. What it will do? Okay, then after getting, that's it. Your duty is over. As a end user point of view, your duty is over. But after receiving it, what Hadoop will do? It will, after receiving that file, it will break the file into blocks. Okay, and it will keep 3 copies of the blocks here. Okay, and also along with the file structure, it also having the block information also in the form of metadata. Okay. So this is what actually
is node manager and resource manager are different.
Yeah, that is used for processing, data processing.
No, is a different, physically different system, or it is same?
No, same machine only. In the same machine, 2 services will be running.
Okay. The end user will be interacting with the master machine.
No, cluster actually. Yeah, master only you will be contacting. You are not contacting the slaves and all.
And that will in turn contact with the clusters.
Yes. That's what. Actually, you are contacting the cluster. That means that virtually you are contacting the name node. Okay. If you want to read some file, okay, I want to read this. So what you will do? Read in the sense, in the Linux, actually cat command is there. CAT, and you specify the file name. Okay. When we are passing that command here, then this name node it will look at where is that file. Okay, it will look into that file. Okay, that file is there. This file is having these many blocks, and it will join all together, and you can view the data. That's it.
Sorry, the replication factor is only available for the cloud version, or it's?
I couldn't get you.
A replication factor, yeah. So it's when you are using only in the cloud, or it's
anywhere in the cloud, or it's like a. See, here you have to understand one thing, that if you are setting up your own Hadoop cluster, you are having your company there. Okay, then what you do? You buy a machine, and buy a server, and you buy multiple machines. You set up your network. You install Hadoop. You can use it. So it is up to you to handle everything. Okay, instead of buying the physical machine, setting up the network, and you maintaining all those things. Okay, to overcome these kind of constraint only, we are going for cloud, because in the cloud already they are having virtual machines already there. Okay, they provide machines. So machines in the sense, they will provide cores only. They will allot some there's some 8 cores and 16 GB RAM as a one machine like that. They will all those, the background setting up the network, everything they will take care. Okay, so when you are getting like a same, like when you are setting up a cluster in your own environment, the physical machine, so you have to install everything. The same way only in the cloud, just they will provide empty machines only. In the empty machines, we have to install.
Okay. But for replication, which means you have to pay, yeah, since it takes up the space, the storage, yeah.
Yes, absolutely. So when installing this, and after installing the Hadoop, the configuration file will be there. So you have to go into the configuration file. All the default configuration will be there. There actually you have to some kind of administration work is there. You want to change something, you have to fill. Okay, and what is the IP address of this machine, all those information you have to fill it up.
Yeah, one more question. As you said, Hadoop only works on Linux system.
Yes.
For example, if we are as a very startup user
Okay.
who will work on Jupyter Notebook.
Okay.
Directly, how we can we import from directly in the Jupyter, whatever the Hadoop data is there? Because
yes. I mean, like end of it, actually, we'll have a practical example. It's not actually, we are not, R actually, we are using Spark R. Okay, in the final session, we'll be having it. Using R, we'll get the data from Jupyter, I mean, like from the Hadoop only, even from Jupyter Notebook. See, Linux is an OS only. Okay, so I'm informing you one thing that tomorrow, I'll share one link to you. Okay, that is having a virtual machine. So inside the virtual machine, everything is already installed. I mean, like it's on the on top of Ubuntu. You don't need to install any software at all. Just download that machine. Okay, inside Ubuntu, on top of Ubuntu, Hadoop, Spark, Anaconda, R, everything is there. It's a complete data science machine. I personally developed for this LearnBay only. This LearnBay, okay, it's a complete. I mean, like a data science machine. Everything is there. Instead of using your own laptop, just getting into that virtual machine. So you can have a different experience that you can work on the Linux environment.
Do we need to have R knowledge to learn the big data?
Nothing. No, not at all. Actually, there is a model that Spark R is there. Like, you write the code on R and, you can implement on top of Spark.
As part of this course, so are we going to see Spark in Python, Scala, or as you said also?
Scala.
So which one are you going to show us?
Scala.
Scala one.
Yeah, we will have one separate session for Scala.
Okay, what about PySpark? So is that not covered?
No, we are not using PySpark actually. We are using only looking into the Scala part only.
Okay.
Because the course duration they have given 9 hours only overall, 9 to 10 hours only.
Okay.
So
actually, I have some. I work on Spark Scala actually, so I just wanted some information on PySpark. So connect with you offline.
Yeah, sure.
Yeah, I'll connect with you.
Okay, so I think you might be having my number. Otherwise, Abhishek will add me into this group and all. You can get my number. You can reach me anytime.
Okay, sure.
Okay. Yeah, somebody you asked what is metadata. Sushma. Metadata in the sense nothing actually. So meta in the if you see any browser and all. See, for example, in the browser when you are looking into the views source. Okay. Something here and there, this actually we call it as some kind of metadata will be there. I'm not about something. If you look into this some metadata will be there. So metadata, why we are using in the sense, so that is readily available. Okay, sometimes some kind of data will be there. It is readily available, so that you can immediately from there you can immediately get them. Some cookies will be there and along with the metadata only. Sometimes, so that whenever you are looking into some page, you are getting the information quickly. That is the metadata. Okay, but whenever it is storing the data in the form of metadata. Okay, we call it.
Hello. You said copies of the data will be stored in the slave machine, right? And the information will be stored in the RAM of the master system. Then if we restart the master system, then how can we access the copies?
There is a risk is there actually. This risk is actually there with the Hadoop version 1 only. So I'm talking about till 2014-15 and all. 15 onwards, I think Hadoop 2 came. 14 onwards. Okay. Until then, one version will be there. But in a 2 version, actually, it is like there is a concept called high availability. We will be looking into that later part of this session. High availability. Using that, actually, we can easily tackle that one.
Okay.
Fine. Okay. The copies of blocks will be stored on different nodes always, or we can control that. I said earlier, we cannot control it. Okay, we cannot say that which block has to be on which machine and all. That actually the Hadoop system is having its own algorithm. So based on its algorithm only it will be storing. I said, one criteria I said that it will be evenly. It's like a, it won't be like one machine is having 80% storage capacity, another is having 5% like that. Okay. More or less everything will be, if it is like one machine is having 40, if you look at the other machines and all, maybe 35 to 45 like that, 45% of only it will be there evenly. That one criteria. And other thing is that based on your node, these blocks and all, how we are storing the blocks in different part and all. Okay, that also important. I mean, blocks should be in different blocks and all. Okay, sometimes the first and second block won't be in the next immediate machines, because if there is high chance that because of some issue, two machines will go down continuously. Okay, that's why always first block will be there, second block it will be keeping somewhere something different. Different algorithms are there. So Hadoop will take care. We cannot understand how it is looking into that. Yeah. Stored in different nodes always. Okay, fine. Right. So okay. Yeah. So once again, I'll coming this particular part. Yeah. So it's like the reliability. I think you understand. Once again, I'll say, so Hadoop will store in the form of blocks only. Okay, the block size is 128 MB block size, and always 3 copies of blocks will be there throughout the cluster. The reliability is achieved. And I'm before closing this session, I'm giving like two more important points. Okay, regarding the blocks. Okay, the block size is except last block, everything will be 128 MB. That's the key. Always that's the keyword actually we have to use, except last block. Okay, and every block will be having 128 MB. So what is that meaning in the sense? If you're having someone 130 MB file, okay, so how it will store? It will store one block is 128 MB and second block will be having 2 MB. Okay, so in case if you're having 500 MB file, 500 MB file in the sense, okay, it will be having 3 blocks. Okay. Because 128 into 3 will be having 3, so that will come for 256 and some 390, 380, 390 approximately 390. Okay, so all 3 blocks will be having 128 MB. Last block will be having 110. Okay, 110 the size. Okay, that's what the keyword. So you have to understand except last block. Okay, and all the blocks will be having 128 MB. Last part of every block will be having the information about where the next block is there. Maybe this first block, this is the second block. Okay, this first block's last part will be having the information where the second block is there. Okay, so that's what actually this how the indexing is happening and all. Okay, right. And another thing is Hadoop is always good for larger files. Okay, we should not use for smaller files. Why? In the sense, see, if you are having 128 MB file will be coming for one block. In case if you are having 1 MB, 100 1 MB files, you are having 100 files. Each file is having 1 MB only. Okay, but even if it is a 1 MB, it will store as a 1 block only. Okay, so you may, I mean, like if people may get confused in the sense, so the block size is 128 MB. It will occupy 128 MB in the hard disk, but only 1 MB data is there. Remaining 120 say will be unused and all. Not like that. Okay, physically it will be 1 MB. That block size is 1 MB. Okay, the block size is 1 MB. In hard disk also it will be occupy 1 MB only. See, if it is like a 100 MB file, okay, 100 MB file, one block will be there. That will occupy only 100 MB. Okay, there is a 1 MB files, 1 MB 100 files you are having. Okay, that also occupy only 100 MB of storage size only, but you are having 100 blocks, 100 small blocks you are having it. Okay, why we should not use the small files in the sense? Okay, the storage is not an issue. Look at here metadata. You look at the metadata. If you are having small files and all, unnecessarily it will occupy the memory. Okay, the size is same only, but it is unnecessarily occupied because each file will be having folder structure, the namespace, and each file will be having that block information and where the 3 copies are, all those information. Okay, unnecessarily it will occupy your memory of this master node Okay, and also sometimes if memory is more and all, that will slow down your machine. So Hadoop is meant for bigger files only, not to use. It is not advised to use the small files. Okay, so this is the key points. So we need to understand this one. Okay, right. So I'm winding up the session.
But 128 MB default, we can change higher size, right?
Yes, yes, that's what I said here. This 128 MB block size is here. Default configuration, you can change it. Okay, based on complexity of that particular file, for what purpose we are using it, you can change any size and all. Okay, and while storing individual files also, you can change it. Default is 128 MB, but you know, the programming wise, this particular file I want to store only on 256 block in the sense, so you can change. Individual file also you can change the size. Okay, so I'm winding up till now, so till the slide number 9, and till now only even the 9th slide is taking the whole session. From tomorrow things will go a bit fast and all. Okay, so I'm winding up, and it's like a question answer session. Okay, if you have any doubts, clarification, you can ask me. I'm here to answer for you. Okay, I hope you all people are fine. Okay, what I will do, I'll share the G Drive link. Okay, maybe I'll get that one. If not, you know, I have to search the G Drive. Already informations are there, and along with this notepad, whatever we have seen, this notepad also, I'll store it. If not, you know, tomorrow when the session start, I'll give you the link.
Sorry, I have one question. Yeah. So you say the default is 128. Yeah, but if we change it to 256, let's say, yeah, the speed will change as well, or it will not affect.
Definitely, it will change. Yeah, if it is like 120 MB file, when you are processing that, it will taking 1 minute. This 256 MB file definitely will take 2 minutes. 2 minutes. That's what I'm saying. Scenario. Sometimes you are thinking that that particular file, you are not looking the result immediately because some kind of query will be running at midnight only. Midnight it will run and it will send you the report. Or you will be looking on the morning only. So you are not looking for, you don't mind about the taking time and all. So those kind of files and all, you can go for bigger blocks. Because you are going for bigger blocks, you are reducing the burden of this name node RAM metadata. You are reducing the burden. That's what, based on the scenario, okay, you can change the file. Got it?
Okay.